Welcome to another informative episode of AWS Solution Architect Associate Exam Question Series on Exam Tricks and Tips channel. Please like, share, and subscribe to get regular updates on new episode releases.
Welcome to episode 14. We'll cover questions 66 to 70 in this episode. For questions 1 to 65, please refer to previous episodes of this series. Let's get started. A business administers its own Amazon EC2 instance, which are configured to operate MySQL databases. The firm manages replication and scaling manually as demand grows or falls. The organization needs a new solution that makes it easier to add or remove computing resources from its database layer as required. Additionally, the solution must increase speed, scalability, and durability with little work on the part of operations. Which solution satisfies these criteria? So what do we have in terms of overall problem description here? We have Amazon EC2 instances that a business owns, and it operates a MySQL database. The firm manages replication scaling manually. The organization need a new solution that will make it easier to add and remove computing resources. So we basically need an auto scaling solution, self-manage, managed service. Now let's see what options we have and what is the correct option out of all of this. I will try to eliminate the obvious wrong ones first. So first one wrong to me, if you look at option C, it says let's combine the databases into one larger MySQL database and run larger database on larger EC2 instance. Now, whenever anybody talks about vertical scaling and having one single instance or a database of larger size, it's always a wrong option because that's not in line with the architecture principles. You want to be, distributing your load. You will be always creating horizontal scaling, and that's how you will work with respect to, scaling your solution. So this does not address also, automatic scaling and managing replication, and manual effort will be involved. And any solution says let's increase the instance size or larger database, it's never a correct answer from AWS certification examination perspective. So option C is wrong. The next one wrong in here is, it says, option B, it says migrate the database to Amazon Aurora serverless for Aurora PostgreSQL. Now this is, if you see, our requirement is that we have MySQL, and this particular solution is not going to be compatible with MySQL. So on that, definitely we rule this out. And obviously we don't want to do any significant changes to application code in order for this solution to fit into the problem that we have. So that's gone. So that leaves us with option A and D. Now let's see, what do we have here? Option D. So in this option, we are uh, doing auto scaling of compute resources, but then there's nothing happening with respect to database requirements. You will still manage the replication and other database related tasks manually. So this is not a correct answer. So option D satisfies half the requirement. So that's wrong. And that leaves us with option A, migrate the database to Amazon Aurora serverless for Aurora MySQL. Now, as you can see, this is Aurora MySQL, not PostgreSQL, so it's correct. And it's basically similar to option B, but it's the right SQL technology. It's serverless, so it will be, self-managed, scalable, and you don't have any operational overhead to manage a solution. But so this is the correct answer. We will dive into the details of characteristics and advantages of this particular option on the next slide. So let's go over it. First one. So the first one is, this is a fully managed solution. So serverless is a fully managed service that automatically scales computing resources up and down based on your application's need. This means that you don't need to manually manage replication and scaling, as the service takes care of it for you. So that was the key requirement, and that's done. It is serverless, obviously, again, extension of what we just discussed. Any operational overhead because of managing instances is gone. And the third is MySQL compatibility. Aurora Serverless is compatible with MySQL, which is the database engine in the business currently. And this makes migration process smoother, and you don't need to change your application code because you're using the same SQL tech that you have in current business. So that's it. Question number 67. A business is shifting to Amazon Web Services Cloud. The initial workload to move is a file server. The file share must be accessible through server message block. Which AWS managed service satisfies this criteria? So let's go over problem. Let's identify keywords here. So what we need to do is, it's a migration to Amazon AWS Services Cloud problem from on-prem, and the service or the resource that we are trying to move is a file server, and we are looking at SMB protocol as the criteria. And if you have done this in past, probably in Cloud Practitioner, we know if you want to support SMB protocol, you need to go for Amazon FSx. That's the one used for Windows-based file systems. But let's go over each option and see why they are incorrect. First one wrong, obviously, is option B, Amazon EC2. Now, Amazon EC2 is a compute service. It can provide you a platform for doing any computation or a computing instance. It is not a file service. So absolutely wrong option for this requirement. The next one wrong, almost as bad as option B is Elastic Block Store. Now, Block Store is a block level storage that is used with Amazon EC2 instances. It's not a file system solution. So that's wrong as well. Look at option D. Now, Amazon S3 is object storage. It's not a file system, and it does not provide any native support for SMB protocol. I mean, you can use S3 as a file system, but this is definitely not going to provide SMB protocol. So that's wrong. And that leaves us with option C, which is the correct option in this case. It's a fully managed file storage service with SMB access. So that's the correct answer for this particular question. It's an easy one. You just need to know if you need SMB protocol or Windows-based file system access in AWS, then you need to go for Amazon FSx. I don't think we have covered Amazon FSx earlier. So here is a reference documentation for you. And the key point here, you can see it provides fully managed shared storage built on Windows Server. That's the reason why we've gone for this particular option. That's it on this question. Let's move on to the next question. Question number 68, a business want to transfer two apps to AWS. Both apps handle huge number of files concurrently by accessing the same files. Both programs must read files with a minimum of delay. Which architecture would a solution architect suggest in this case? We have a business, they have two apps, and these apps are going to handle a huge number of files concurrently. And we want to make sure this is a performance solution and we have minimum delay for reading the file content. So we have various options here. Let's see which one is the correct one. We'll have to go by elimination rule here. So first option A, it says let's configure two Lambda functions to run application, create an Amazon EC2 instance with an instance store volume to store the data. Lambda functions are serverless and stateless, but they're not ideal for running applications that are long running file access, because we know Lambda function expire after 15 minutes of usage. Instance store volumes are volatile and data is lost on instance restart. So that's not recommended. So wrong answer in both the respect. Lambda function are short-lived. Also, instance-based storage means if the instance restarts, you would be not having access to the data. So that's gone. Option B says let's use, it's sort of similar. Let's see what the option says. Let's use two Lambda functions and create an Amazon EC2 instance with Elastic Block Store volume to store the data. Now, it's similar to option A, and Lambda is not the right solution. Option B is extension of option A, but we are changing EC2 instance with an instance store to EBS store. Now, EBS volumes can offer good performance, which is all right, but you cannot attach it to multiple instances. It has to be attached to a single instance at any point in time. So you cannot use that as the solution for concurrent access from both the apps. So that's wrong. Then the next wrong is C. Option C says configure one more memory optimized EC2 instance to run both applications simultaneously and create a EBS store volume with provision IOPS to store the data. While single EC2 instance created in this way can provide good performance for reads, it creates a single point of failure. Additionally, managing concurrency with the application running on the same instance will add complexity. So this one partially addresses the question. And we all know for addressing such a concurrent file access problem, we have a service for that, and that's Amazon EFS, Amazon Elastic File System. When we have a purpose-built solution like that, which is in option D, why would we create this makeshift solution which partially fulfills one requirement, but while doing that, it creates a much more complex scenario? And so option C is wrong. So the correct answer for this particular problem is option D, to use Amazon Elastic File System. This configuration allows both applications to concurrently access the files with minimum delay, and it provides some level of automatic scaling with bursting throughput as well. So that's the correct answer for this question. Option D, EC2 plus EFS. The correct answer is EFS, but along with that, obviously, we also need to figure out the first part of the application. So option D says, let's use two Amazon EC2 instances to run both applications. So you have distributed control and you have decoupled the application. You have each of the app is running on a separate EC2 instance. And then these apps then will access a common Elastic file system, and it would allow concurrent with minimal delay in read. And it also will provide some level of automatic scaling with bursting throughput. So this is the correct answer. Different EC2 for running your apps and use of EFS for concurrent file access. So that's your answer. And here is a reference article from AWS documentation. So I'm trying to zoom in on the section of the article which talks about concurrent file access here. As you can see in the paragraph 3, you can use Amazon EFS system for concurrent access from different NFS clients and applications. So that's the answer for this particular question. That's it on this question. Let's move on to the next question. Before moving on to the next question, if you're finding this analysis and discussion useful, then please hit that subscribe button if you're not already done it. Thank you. Question number 69. A corporation operates a containerized application in an on-premises data center using Kubernetes cluster. The organization stores the data in a MongoDB database. The organization want to transition some of these environments to AWS, but no modification to the code or deployment methods are currently feasible. The business needs a solution that lowers the operating cost. Which solution satisfies these criteria? So let's understand what are the keywords here. We have a scenario where a corporation has lots of on-prem services. It has a Kubernetes cluster. It has MongoDB database. Organization wants to move some services to AWS. So it would be a hybrid scenario, but they don't want any modifications to the code or deployment methods. That means you cannot do a lot of changes to the technology. So let's see what options we have here and what is the correct answer for moving this solution to cloud, moving some services to the cloud and keeping the operating costs lower. So the first one says, let's use Elastic Container Service in Amazon and EC2 worker nodes for compute and MongoDB on EC2 for data storage. Now, this meets Kubernetes requirement because we are using ECS, but it will require managing EC2 instances for MongoDB as well as for ECS. That would increase the operational overhead. So you do not have a serverless solution here. So that's not going to work in terms of lower operating cost requirement. So we rule that out. The next one wrong to me is option B. Says let's use ECS with Fargate for compute and Amazon DynamoDB for data storage. So I think the first part is all right. Usage of ECS with Fargate instances, that's serverless, so that will be good in terms of operational cost. But the second part, which is the database choice, DynamoDB is a NoSQL database, and it's not compatible with MongoDB, which is document DB storage, and it's not going to work. So and if you have to make it work, obviously it will need a lot of code changes. And we have a requirement here that we don't want any modifications to code or deployment method. So that's gone. So option B is ruled out for the choice of database in this case. Then we have option C. In fact, that's the worst of option A and option B. They're using EC2 worker nodes, which needs management of EC2 instances, and also using DynamoDB, which is the wrong choice of database on the from option B. So option C is incorrect as well, and that leaves us with option D, which for compute you have Kubernetes service with AWS Fargate instance type. So that's your serverless option, and that's going to keep the operational overhead low. And for managing the database side, we have Amazon Document DB, which is compatible with MongoDB for data storage. So that's the perfect solution. So this is overall, I think, two-part problem. You need to choose the right service for compute, and you need to choose the right service for database. So correct answer for this particular question is option D, use of EKS with Fargate instance type and use of Amazon Document DB as your database storage. What are the characteristics and advantages of this particular option? So the first one, no code or deployment. As we saw, both the services, compute as well as database, both are compatible. So there is no code or deployment changes needed. Second one is low operating costs. We've gone for serverless solutions here. In case of AWS Fargate, it's a serverless compute engine, and also you don't have to manage any EC2 instances underlying. In case of document DB as well, it's a fully managed service. So from a database perspective also, you don't have any operational overheads. And Kubernetes compatibility, that is one of the requirements. So that's not a big one. And MongoDB compatibility, I think that's we have covered in option the first aspect, which is no code or deployment changes, because we are going for compatible solutions and tech in case of compute as well as database. Number 70, a business has a mobile chat application that utilizes an Amazon DynamoDB data storage. Users want as low delay as possible while reading fresh messages. A solution architect's objective is to provide optimum solution with the fewest possible more application modification. Which technique should be chosen by solution architect? So what do we have in terms of problem description and keywords is we have a mobile chat application and it is using DynamoDB as data storage, which is a NoSQL database and a very high performing database. User wants low delay for reading fresh messages, and we want to make this with fewest possible modifications. Let's go over the option. But to be honest, this is a very simple problem. In order to solve this problem, what you need is you need a caching solution. You need to use the caching solution available in case of DynamoDB, which is DynamoDB Accelerator. And that solution, you can get an optimum low latency read with minimum application modification because you're using caching, and this will be the most simplest solution to build. So the simplest solution in this case will be to use DAX, DynamoDB Accelerator Cache, and that would give you low latency reads with minimal application modifications, and it will be a managed service for caching and scaling. That will be our answer, but then let's go over other options, why they are incorrect. So option B says read, let's use read replicas. Now this will not provide same level of low latency reads as DAX and would require significant modification because you're going to create replicas, and replicas is never an answer for minimizing the read latency. That is good for separating a reporting load from a transaction load and thus improving the performance of the system, not in this particular problem scenario. The next one is double the number of read capacity units for the messages in table in DynamoDB. Continue to use existing DynamoDB endpoint. Now this would improve read performance, but it would not be as efficient or cost effective as using in-memory caching like DAX. So this is going to, on ongoing basis, will cost you a lot more. Caching will be much more efficient and cost effective solution. So option C is not correct because you have a better option. Option D says let's use Elastic Cache for Redis cache to the application stack, update the application to the Redis cache endpoint instead of DynamoDB. Now this will help. This will improve the read performance, but this is not a purpose-built solution for DynamoDB. This will not be as efficient or cost-effective as using an in-memory cache like DAX. So it's a very simple problem. If you know DynamoDB and usage of DAX, you'll be able to answer this very quickly. This problem doesn't really warrant elimination of options. You should just go for the correct answer, which is option A here, usage of DAX for improving the read latency. So that's the correct answer for this particular question. And I believe this is the last question of this particular episode. I'll see you in the next episode of this series soon. Thank you.
This is Exam Tricks and Tips. You're watching the AWS Solution Architect Associate Question Series. See you in the next episode. Thanks for watching. This is Exam Tricks and Tips. You're watching the AWS Solution Architect Associate Question Series. See you in the next episode. Thanks for watching.